Hello. I'm going to provide a couple example problems on the mechanics homework. So these are examples to some mechanics problems associated with mechatronics. First one we have is here. It looks like I've got some kind of base for a omni-wheel robot. I've got a schematic here below, sort of a free body diagram / schematic. It says you are designing a robot omni-wheel drive system. The shaft diameter is 10 millimeters. I guess that's D. The length is 20 millimeters. I'm guessing that's L. And that says a wheel center to entering motor. So I guess here's where it enters the motor, and then this would be the wheel center. The motor gear head has a stall torque of 3 Newton meters. So if I had a torque over here, it'd be 3 Newton meters stall. Mass of the robot is supported by a single wheel is shown, and it's 5 kilograms. So I guess there's 5 kilograms coming down here, but it looks like I've inverted the problem holding that fixed. So I guess that'd be equivalent to putting 5 kilograms here on the wheel. The shaft material is 6061 aluminum, yield strength of 240 megapaw, ultimate strength of 290 megapaw. Assume the motor is not engaged to the shaft. So I guess that means we don't have to worry about that torque. It's not engaged. What is the maximum stress in the shaft when the motor is not engaged? Enter the values in megapaw. Well, we have kind of 3 stresses that we talked about. There was axial stress, where I'm pulling my member apart. There was torsional stress. That'd be like transmitting torque out of a motor. And then there was bending. We don't have a motor. We're not pulling apart. In the case of bending, kind of looks like that's what I have now. I'm fixed on this end. I'm pushing down here or pushing up here, and that causes the thing to bend. So it looks like that's what I have. I jump to my notes, my summary notes. It says the bending stress sigma is given as my over I, where it's suggesting that, well, it doesn't quite tell me, but I know my moment would be a force acting at a distance, or an R cross F. I guess I like to do the R cross F. Be like an L cross R, R cross F, excuse me, but I'm just going to write times FL. My Y is 1/2 the diameter of my shaft. And I do note that there's a little mistake in the notes on that. And it actually suggests that for a solid circular shaft, and it's calling this a shaft, so let's going to assume that's a circular shaft because it's coming out of a motor. That's probably a reasonable assumption. The I, either about an XX or a YY, it's equivalent for a circle, would be pi over 4 R to the 4th. Okay, so I think we can put these things together. So our sigma is going to be our force times the length times d halves all over pi over 4 d halves to the 4th. Here our force is that mass times gravity, so 5 kilograms times 9.81, that's gravity, and the units there are meters per second squared. When I multiply those, that would be newtons. The diameter is 10 millimeters, which I'm going to write in meters. I'm going to put that in meters. So 10 millimeters would be 0.10 meters over 2. Oh, I forgot my length. We need the length. The length is 20 millimeters. So I'm going to write that as 0.20 meters. Times my d halves. My d is 10 millimeter shaft diameter, so that's 0.010 meters. But I need the radius or diameter over 2. And the denominator, get pi over 4, 0.010 meters over 2. I take that to the 4th. Let's see, in the numerator, we're going to get kilogram meters per second squared. That'll be newtons I'm gonna get a Newton meter squared, the numerator, and the denominator will get meters to the fourth. That'll give me meters squared, Newton meter squared, which is a Pascal. So I'm gonna run this through my calculator. I get work. I get 5 times 9.81 times 0.020 times 0.005. I did that 10 divided by 2 in my head. Okay, I'm going to divide all of that by pi. Got pi here times 4 divided by 0.005. Again, I picked a 10 divided by 2. And my lights went out. I'm going to raise that to the fourth. I can't even see. Hold on. I got these smart lights and they turn off on me. Sorry. Okay. Equals. Oh, gosh. Let's try that again. That was not the right answer. I mean, I should be getting something large, not really small. Let's try that again. So 5 times 9.81 times 0.020 times 0.005 divided by pi divided by 4 times 4 divided by 0.005 raised to the 4. Eh, okay, let's try that again. That's e to the minus 12. I'm gonna try one more time. I should get a big number. Okay, let's try it again. 5 times, I can see what I did wrong. 9.81 0.002 times 0.005. Okay, divided by pi times 4. Now I've got to continue dividing. That's what I did wrong. Divided by 0.005 raised to the fourth. I'm feeling good about this one. Eh, Well, somehow I got off by a factor of 10 right here in that 0.002. Let's try it one more time. I think I'm close. 5 times 9.81 times 0.02 times 0.005. Okay, divided by pi times 4 divided by 0.005 divided the fourth. I'm less confident than I was last time. Okay, I'm going to check my numbers. 5 times 9.81 times 0.02 times 0.005 divided by pi times 4 divided by this. Okay, I'm feeling good about that. So that's my answer there. I think 9.992. Well, it's 9.99 e to the sixth. So 9.99 e to the sixth pascals, or 9.99 megapascals. And it asked me to enter the number in megapascals. Okay, so that's my answer.